Hi everyone, today's topic is scale drawings. So scale drawing is actually a reduced or enlarged drawing of an actual object. So people who work in science, engineering, construction, and architecture often use scale drawings to basically plan out what they're about to do and to maybe showcase and present an idea for somebody else before they actually make the object or assemble it together. We are going to talk a bit more about scale maps, but here is an example of a scale map. Um, Often, when you open up a map, you'll actually find what's called a legend on the bottom to basically show you, like, hey, it may look like, Albany and Buffalo are just 1 inch away from each other, but this is actually a scale map, and 1 inch on this map actually means 200 miles. Okay, so they're basically taking a big object or a big distance and they're scaling it down or reducing so that you can kind of get the bigger picture and look at it kind of from a bird's eye view, so that you can get a better idea of what's going on. And again, it's used a lot for planning. And here are some other examples of scale drawings. So often, I actually use this method as well, where I'll basically find like a picture online, and if I need to kind of blow it up and make it into a bigger drawing, I'll basically take a projector and I will project the picture onto a larger piece of paper or something, and then I can just basically trace over it. And I'm letting the projector basically basically be my cheat to enlarge it. So you can use scale drawings to reduce or you can enlarge. Some of you also might be familiar with this mural that's actually on King Street. I think they actually put it up a year ago. And here's an article on CNN Style in the arts section. It says Hawaiian artists' enormous murals are ambitious in scale and message. So you probably have seen this down on King Street. And it basically is showing Duke, who has a lot of historical connections, helping popularize the sport of surfing, and then Carissa Moore, who ended up competing in the Olympics for surfing and doing very, very well. So this is actually a huge mural that you can find on the side of a building in King Street. And so what this artist had to do as well was sketch out what this mural would look like on a piece of paper. And then eventually, when this design was then approved, then he had to take this piece of paper, that drawing, and make it into a much bigger drawing. So muralists definitely use scale a lot. All right, so here we see that the artist is so small compared to the actual mural that he actually has to create. Wow. So he had to change a scale drawing, like a piece of paper, into this ginormous mural. So math is very important here to be accurate and to just realize the original design, right? Yeah, if you ever get a chance to drive down King Street, it's amazing. Scale factor is basically a ratio, a special ratio that you use in a scale drawing. And it's a ratio that basically tells you the length in the drawing and how it actually corresponds to the length in the actual object. So just like in a map, that muralist will then have to be like, okay, well, 1 inch in my picture is actually going to be like several feet in my mural that's going to be on the side of a building. So they have to use a lot of math to then transfer that image onto a bigger canvas. Okay. So we're going to talk more about that, but basically you do have to remember that a scale factor is like that legend, that key that tells you how it actually corresponds to the actual object. The scale drawing is a reduced drawing of the actual object if the scale factor is less than 1. Okay, so if it's a fraction or a decimal, then you know, oh, okay, so that means that this scale drawing is smaller than my actual object. And conversely, if it has a scale factor that's larger than 1, then you know that it's an enlarged drawing. So you're taking something small and making it bigger, actually. The scale factor of a drawing is also known as its scale. So you'll hear somebody say scale factor and also scale. A scale is usually expressed as a ratio 1 to n, or a fraction 1 to n, where 1 unit length on the drawing represents the actual length of n units. So be sure that this stuff goes into your notebook. Again, I'm going to use this map as an example. So we have right here the legend, this scale, and the scale factor shows us 1 to, what is this, 12,672,000. So basically it means, okay, whenever you measure 1 inch on this map, it actually is equal to 200 miles, which is actually 12,672,000 inches. So they're showing it to you in inches to miles, but also inches to inches. If you were to actually then, figure out how many inches it would be. Same over here, 1 inch here equals 1 mile, which is the same as 63,360 inches. In case, you need to use that to figure out the actual distance. Okay? Okay, let's take a look at example 1 from your book. They want you to express each of the following scales in the form 1 to n. So just like the map that we showed previously, 1 to whatever the equivalent is in that exact unit, 1 to whatever that number is. Okay, so for part A, I have 1 inch on my map or picture is corresponding to 200 feet. It's basically representing 200 feet. So what I do need to do first is to change them both to either inches or feet. Now it's going to be much easier to change my feet into inches because I know that there's 12 inches in 1 foot. So I could solve this in 2 different ways. I could know in my brain, like, okay, feet, if I need to change that into inches, there's going to be way more inches because there's a lot of little inches that make up 1 foot. So I can multiply by 12 to figure out how many inches there are. Okay, so then this would be 2,400 inches in 200 feet. So then this answer will be 1 to 2,400. The other method I could use is I can remember from converting units that if I wanted to convert 200 feet into inches, I can take the fact that 1 foot is equal to 12 inches and set it up this way so that I cancel out my feet together. And then I know, okay, I have to multiply them together to get 2,400 inches. That's if, you get kind of confused, like I do sometimes, about whether I'm multiplying or dividing. Remember, you can always use your conversion factors to figure out your answer. You can also get your 2,400 inches that way. But remember, at the end, they want you to write it in the format 1 to n, 1 to 2,400. And the reason why we can reduce that to 1 to 2,400 is because at the end, we have both inches. So then since they're the same units, we can basically get rid of those units, and because we're comparing inches to inches. Okay, let's look at B. B is using the same concept. So for B, they have 1 centimeter corresponds to 50 meters in real life. So this is what the map shows. This is what's in real life. We need to put it into the form of 1 to n. Now I can look this up, or I can already know that 1 meter is equal to 100 centimeters. Centi means 100. On a test, I would give you this information, so don't worry. Or you can look it up when you're at home. Just do a quick Google search, okay? But you're not required to memorize that. So if you're at home, you can Google it, how many meters or how many centimeters are in a meter. And on a test, I would give that to you. All right, so I need to change them both to centimeters. So why don't I use my conversion factors to kind of help me out? Because let's say I'm confused on a test and I want to make sure that I have it correct. 1 meter I'm going to put on the bottom so I can cancel out. 1 meter is equal to 100 centimeters. So this means I multiply. So at the end, my answer is 5,000 centimeters. So really I multiplied and I got 1 centimeter to 5,000 centimeters. So my answer at the end is 1 to 5,000. So what that means is on my map, I may see 1 centimeter, but it actually really means 5,000 centimeters in real life. Okay, and now let's look at C. C is it has 3 feet to 4 inches. Okay, so I want to get it down to 1 to n. All right, I know from before that 12 inches equals 1 foot. So let me change them both to inches. If I have 3 feet, 3 feet over 1 times 1 foot on the bottom so that I can cancel corresponds to 12 inches. So that means I multiply and I get 36 inches. 3 feet is the same as 36 inches. Okay, normally I would just get rid of these units and then I put 36 to 4. However, the problem wants me to write it as 1 to n. So I'm not done yet. I need to get that 36 to become a 1, and I need to do the same thing to both sides. That's not bad. How can I get 36 to get to a 1? Well, I can divide by 36, and I need to do that on both sides. So 36 divided by 36 is 1. 4 divided by 36, let's keep it as a fraction. Let us, reduce by 4. So I end up with 1 to 1/9. That's my answer. On my map, I'm assuming in this case, whenever I see 1 inch, it really corresponds to 1/9 of an inch. So remember, a scale factor that's less than 1 means you're actually looking at something that's actually smaller. So maybe this is, I don't know, like a small bacteria or something that we need to blow up so that we can, actually understand it, because it's too small for us to understand. So we actually have to go in the opposite direction. That happens as well. Okay, now let's move on to example 2. A soccer field is 300 feet long and 240 feet wide. It is represented by a rectangle with length 6 inches on a plan. So the 300 feet is really equal to 6 inches on the drawing, right? Because the soccer field is really big. They're only representing it on a little drawing where the length, which is actually 300 feet, is represented by only 6 inches. Find A, the scale of the plan, and B, the width of the rectangle on the plan. So they don't know how they would represent it on the plan using this. Go ahead and pause the video and try it on your own first. Okay, so the scale of the plan, remember, that's where we have to write it as 1 to n. They already told us this information, that the 300 feet in real life really just looks like 6 inches on the plan. So we can use this information here to figure out the actual scale. So we're going to set it up like our previous problems, right? Our example 1 kind of looked like this, right? So we got to set it up so now that it's 1 to n. Well, right now it's 6 inches to 300 feet. We know that there's 12 inches in 1 foot. So let's figure that out. If it's 300 feet, then I'm going to multiply by 1 foot on the bottom to equal to 12 inches. Those cancel. I'm really multiplying. So this is 3,600 inches. So 6 inches corresponds to 3,600 inches when I change feet into inches. Then I still need it down to 1 to a number. So let me erase this so I have more room. How do I get my 6 to get to a 1? Well, let me divide that 6 by a 6, which means I have to do the other side, the same thing. 6 divided by 6 is 1. 3,600 divided by 6 is 600. So this is my scale, 1 to 600. Every time I see 1 inch on my plan, it really means 600 inches in real life. But I'm just putting it down to a scale that's more manageable. So 1 to 600 is my actual scale. Now I'm going to use that in my next answer because now that I know my scale, I can do some stuff with it. Okay, so we know that the actual width is 240 feet. We need to figure out what the width would be on the plan, on the piece of paper. Okay, so my scale is 1 to 600. That's in inches. Right now I have it in feet. So I first need to change this 240 feet into inches. Okay, remember it's 12 feet. Oops, sorry, 12 inches in a foot. So 240 feet over 1 times 1 foot on the bottom to cancel, and 12 inches on top. That'll be whatever 240 times 12 is. 240 times 12, 2,880 inches. Okay, so far all we did was just change our 240 feet into inches, because remember our scale uses inches, so we have to change it to inches so that it matches. All right, now it's basically saying, well, on my plan, every 1 inch is equivalent to 600 inches. So now I have to figure out, well, how many inches would that look like on my piece of paper, my plan then? If I'm basically converting each 600 inches into just 1 inch. Okay, well, if each 600 inches is going to become 1 inch, I basically have to take my answer and I have to divide it into groups of 600, right? So then I'm going to take this answer and divide it into groups of 600. And I'm going to need my calculator for that. That would be 4.8. 4.8 inches. Okay? So on my paper, my plan, the drawing, the width is only going to be 4.8 inches. But we know each one of those inches actually represents 600 inches in real life. So that would be 4.8 times 600 to get to the actual width of my soccer field, which is 2,880 inches, also known as 240 feet. Okay, so a lot of multiplying and dividing. Remember, we divided by 600 because that's what our scale factor from part A told us. That every 600 inches was equivalent to 1 inch, only 1 inch on my paper. So that's why I had to divide it so that I can scale it down so that it can fit in that paper. Let's take a look at example 3 now. It says the diagram shows a floor plan of a kitchen, which is drawn to a scale of 1 to 50. The dimensions of the kitchen in the plan are 6 centimeters by 4.5 centimeters. Find the actual A, dimensions of the kitchen in meters, and B, the area of the kitchen in meters squared. Pause the video and try it on your own first. Okay, so let's start off with the information that we have. It says that the scale is 1 to 50, so basically every time we see 1 centimeter, it actually means 50 centimeters because they've reduced the actual dimensions. And they're giving us the length and the width. We had to find the actual dimensions in meters. So at the end, we still have to change it into meters. All right, let's see. I have 6 centimeters for my length. But remember, every time we see 1 centimeter, it actually means 50. So I'm going to take this 6 centimeters and multiply it by 50 because it's actually 50 times longer in real life. So 6 times 50 is 300 centimeters. Okay, that's in centimeters, the length. I still need to change it into meters. Okay, if I look it up, 1 meter equals 100 centimeters. So in order to change 300 centimeters now into meters, I got to take that information and convert it. 100 centimeters on the bottom, so that bottom and top can cancel out, and 1 meter on top. Okay, so this is a division then. 300 divided by 100 is 3. So it's actually 3 meters. That's the length. Okay. And then it says, oh, I still have to figure out the width. Okay, same thing. If I see 4.5 centimeters on my picture, it's actually 50 times bigger because that's my scale. So 4.5 times 50 is how much it's actually in real life, 225 centimeters, because according to the scale, it's 50 times bigger. Oh, I still need to change it into meters. So same thing as before, except now I have 225. Just gonna be lazy a little. 225 centimeters, change that into meters by putting 100 centimeters on the bottom so they cancel. So I'm really dividing 225 by 100. 225 divided by 100 is really moving it over 2 decimal places, so you get 2.25. Okay, so that's the same as 2.25 meters. That's the width. Okay, so that's your answers for A, the dimensions of the kitchen in meters. First, multiply by 50 because that's what the scale told us. Hey, everything you see on this map, it's really supposed to be multiplied by 50 because this is a small picture. So that's why we multiplied by 50. Then we had to convert it into meters because that's what the problem asked for. Because no one's going to be measuring things in centimeters. Oh my gosh, that would take forever. So meters is the preferred unit of measurement. Okay, B. They want to figure out the area of the kitchen in meters squared. No big deal. Area of a rectangle is length times width. We have our length and our width. Let's do it. Length is 3 meters. Multiply by my width, which is 2.25 meters. Now don't get confused by this meter squared. Your problem will take care of that. 3 times 2.25, let's put that in our calculator. 3 times 2.25, that's 6.75. And then meters times meters is meters squared. That's where that meter squared comes from because area is 2-dimensional. So your area is 6.75 meters squared. And we can get all that from a little picture because they just took a huge area and they shrunk it into a smaller picture and a smaller scale.